Hello and welcome to lecture 30 in chapter 19 of our comprehensive course on AI, ML and DS. Now, name of this lecture was originally basic statistics, but then as the chapter progressed, I decided to include so many topics for the sake of continuity that we changed the name of the chapter to comprehensive introduction to statistics. And this is 30th lecture and a few more are yet to come. So you can understand the depth which is covered in this chapter. Now, the whole chapter has three parts. First, measures of central tendency and measures of dispersion. Second, descriptive statistics. And third, central limit theorem and inferential statistics. Now, in inferential statistics, we were doing hypothesis testing and we did a lot of discussion on hypothesis testing and then we studied some tests for hypothesis testing. Single t-test, then paired t-test, then independent sample t-test, that is two sample t-test, then z-test, f-test, then chi-square test, ANOVA, and so many tests. So those who have not done previous last maybe around 8 to 10 lectures, they are strictly advised not to proceed further, particularly with the next chapter and so on, because what we have covered in this chapter 19, that is the brain, heart and soul of data science. So now let us see what is the practical application. We are slowly wrapping up our chapter. So last we have done hypothesis testing, right? So what are the practical applications of that hypothesis testing in data science and business? Now I will go through this part very quickly because most of these applications we have already discussed in much detail in previous around 10 lectures. So this is just a kind of recap. Okay, so somewhere here we want to start. The last topic our was this that is click-through rate and z-test. This was our last topic, right? So now we want to do these practical applications and these are the topics which we want to cover. Hypothesis testing in data science, hypothesis testing in business analytics, hypothesis testing in e-commerce, and some advanced use case of hypothesis testing. Now, at least first three that you will be able to understand, because most of those cases, what we are going to discuss in first three headings, that we have already covered in much detail in previous 10 lectures or so. In this, you might get one or two extra points, but even that we have studied. Similarly, next part which we want to cover is visualization and interpretation of results of hypothesis testing. Even that part we have done in much detail. Hypothesis test output, what is the meaning of confidence interval, visualizing the results, how to report the result of hypothesis tests. So as a data scientist, you should not only learn how to conduct hypothesis tests, but you should be able to report it properly in a scientific manner so that the stakeholders can understand. An example of hypothesis test report and real life examples of hypothesis testing in action. Then one more question is, this is very important question, that choosing the right hypothesis test. That okay, you have done single sample t-test and independent two sample t-test and paired sample t-test and chi-square test and ANOVA and correlation test and z-test and all that. But one important thing is that when to use which type of test. Okay, so that we have to decide, and this is also equally important, common pitfalls and best practices in hypothesis testing. So sometimes even experienced data scientists, they make some mistakes because fundamentals are not clear. Okay, so you should take care and avoid these mistakes. Then finally at the end of the chapter, we will do this thing, three more examples of use of central limit theorem in the business, and there our chapter will end. So currently we are doing this practical application of data science of hypothesis testing in data science and business, right? And as I said, that those applications you will find so familiar because that is what we have been studying in previous around 10 lectures. Because my way of teaching was that with each hypothesis test, we took at least three practical examples and we discussed the code and etc. also for one real life practical example only. So this is why this is just going to be a repetition. For example, very first application, feature engineering and selection. So we have done that often the response variable depends upon several features. It might depend upon even 10 features. For example, in the correlation matrix of that crop yield example, we had done this one. Okay, so the crop yield depends upon this so many features. But if you make a model in which this is your response variable y, and these all are your independent variable x1, x2, x3, then that model is more likely to overfit. So we always first find which variables are highly correlated, and then we, out of, for example, average air temperature, average minimum temperature, average maximum temperature, we found that they have 99 to 100% correlation, then we will keep only one. Okay, then even among them also later on we found that with response variable this is having only 0.02 correlation or 2% correlation, then we dropped even that also. So that means in general all three temperatures can be dropped. Okay, so our model becomes simple. Similarly, we dropped other also. For example, this is having time since last harvest, is having 83% correlation with total radiation. Okay, so in that case you can keep maybe only total radiation, and time since last harvest you can avoid. Okay, so then time, maybe one more also was there, highly negatively correlated, that Julian day, and here day length. Now then it is clear that positive or negative, but these two are having so high correlation, then you can even remove one of them and keep only one. So that is called feature selection, right? And the very first application of the in data science and business is this feature engineering and selection, right? So, and that is done by hypothesis testing. It is not just that from the heat map I found that these are highly correlated and all that, and just therefore remove a few features. We do a proper hypothesis testing and decide if they are indeed affecting the response variable or not. One example is this, that we can use chi-square test to assess whether a categorical variable like marital status significantly impacts the target. Even this example also we have done, that suppose you have loan applicants data from a bank, and in that the information about loan applicants is given, that age, gender, then educational qualification, then salary, then other loans, maybe credit rating. But in that there is one other column that is called marital status. Okay, and finally the response variable is loan approval, whether loan was granted to that customer or not, yes or no. So using that given data, you are supposed to make a predictive model such that whenever a new customer comes, and when you know all other features like credit rating and salary and age and gender and his other loans and his marital status, then you should be able to decide whether loan should be given to that person or not. That is what that model should be able to do with good accuracy, right? Now the problem is here that does marital status affect the outcome or does it not affect the outcome? So for that we can conduct a chi-square test. If you know that chi-square test is exclusively for categorical variable, so this is also a categorical variable and your response variable is also a categorical variable, and then you can say that whether marital status significantly affects loan approval. Okay, if it affects, then you will keep it in the model. If it does not affect, then you will not keep it in the model. Now in real life marital status does affect, and if you are a divorced person or a not married person, compared to that, if you are married and both husband and wife are working, then your chances of getting loan approval improves. Okay. Now model performance comparison. Now there again, suppose you are given some task by some firm, and you are a data scientist who are assigned that make a predictive model. Now you will try several models. You will try say random forest model, and you will try the logistic regression model also. You may try many other models, the long list of models I have spoken often. So try all the models and find accuracy, precision, recall, maybe F1 score or other metrics also using each model. Now the question is, which model will be used finally for the client's task? So obviously the best model which gives the highest accuracy and the good balance between precision and recall, that model should be put, right? Now such a model is found by using paired t-test. So we compare the metrics obtained by random forest with the metrics obtained by logistic regression. That are just two examples. Instead of these two, there can be any other algorithms, right? But we compare the metrics obtained. Metrics means these three things. Okay, by one model with another model using paired t-test, and any model which gives higher metrics, that is selected. A/B testing, that also we have done many times, that we can evaluate different configurations for model hyperparameters. Now that is also important. Suppose you have selected random forest, but in random forest itself there are many different parameters. For example, there is some parameter called n depth. Maybe there is one parameter for n estimators. Similarly, there is one parameter for say learning rate. Similarly, say next sample leaf, or that kind of thing, right? Now I have told you what is the meaning of this each thing. That n depth is the depth of each tree. Random forest is nothing but a forest. It is a collection of several trees. It is a ensemble model. Now n estimators means how many trees you want to take in your collection. Learning rate is actually not much I think used in random forest. It is used with neural network, etc. But suppose max sample leaf, okay, so that is the maximum number of data points which will be included in the leaf, like that. So leaf node of the forest. Then you can use two different sets of the parameter, and you can compare which parameter for same random forest model. One person tries hyperparameters like A, B, C, and A1, B1, C1, and another person tries hyperparameters A2, B2, C2. Model is same random forest, but different hyperparameters will also give uh, different metrics like this. Okay, so as a result, it is clear that you have to choose the best hyperparameter. And if you remember, for that we use grid search CV, which tries hundreds and hundreds of combinations of hyperparameter and which finds the one best hyperparameter, right? So testing if a learning rate of 0.01 significantly improves F1 score compared to a learning rate of 0.1. So that is an example, and for that we can use A/B testing. Then evaluating training strategies. So for example, there is something called transfer learning. Now, this is one very advanced branch, particularly used in robotics. What is transfer learning? It employs computer vision, and it enables the robot to learn. No, that sorry, transfer learning is using a pre-trained. What I was talking about is enables the robot to learn from the environment, but that is reinforcement learning. So sorry, but transfer learning is using a pre-trained model for your task, so that you don't have to train your model from scratch. And as I said, it is a complicated thing, but nowadays that has become very common. For example, this ChatGPT and all that, Llama and all that models you are seeing. Now, ChatGPT is a proprietary model, but Llama and many other models are open source model. Open source means what? They have trained their basic model, okay, and model weights, etc. What is weight in a neural network? I have discussed. So model weights, etc. They have published. Now, 100% open source model will not only publish the model itself, but also put the weights also in public domain. While there are half open source models like say Llama, they don't put the weights in the public domain, but they at least put the model itself in the public domain. So now you want to train that is a general purpose large language model, and you ask any question to it in any domain. Maybe one person asks a domain from finance domain and he gets the answer. Another person asks the from history domain, he gets the answer. Another person asks from maths domain, he gets the answer. Of course, every time these answers are not accurate. We are still moving ahead in that field, but that means that model Llama or whatever, say 100% open source models are also there. So then whatever models have already been trained on so much information, then there is no need to spend money and effort on training it from scratch. What we do is, when we want to, suppose you are running a finance firm and you want to build a small model which can only work in the finance domain, but which will work perfectly. So for finance domain. So what you can do is, you can transfer all the learning which is already contained in that open source model to your model, and you will selectively use that knowledge. That means you will only take that knowledge which is related with your domain, okay, and then you will fine tune your model for your application. So that model, open source model, was say average for everything. So it was say having 70% accuracy for everything in general. But you want a model for finance domain, so you deleted in something like filtered out all other knowledge weights, and you took only the weights related to the finance in your model, but you fine tuned your model so that for your domain it is much higher, much precise and a higher model. So maybe 80% precision compared to that general purpose model, right? So that using the weights and the learning of some already pre-trained model for training your model, which is usually trained for a specific domain, that process is called transfer learning. Now, again, in transfer learning, there are different training strategies. So if you want to compare, strategy X will work best or strategy Y will work best. So in that case, you should use parity test, right? Now that model validation. So model validation means, suppose you have finally made your machine learning model using XGBoost, and using XGBoost also you made 4 machine learning models, one with hyperparameters set 1, second hyperparameter set 2, third hyperparameter set 3, and fourth hyperparameter set 4. Now in these 4 models, which one is the best? So for that, you have to choose one performance metric. So suppose I have chosen F1 score as a performance metric, and then you have to compare the performance metric using ANOVA between those 4 XGBoost models, and the best XGBoost model that you will use for your this production. Okay. Then customer segmentation, that is one very popular and important thing for online retailers. Then or even offline also, but for online it is very important. Then for that we can use chi-square test to decide if purchase behavior of customer differs significantly across maybe some age groups, region groups, some other group also. You can say that purchase behavior depend upon 2 gender groups, male and female, or any other groups you can make. And if it depends, for example, we earlier took one case and we found that a retailer found that his shaving cream, he studied the effect for less than 25, 25 to 40, and 40 to 50, three age groups. But he found that the purchase behavior or the liking or not liking the product, that does not depend significantly for the age group. So there is no need to make three advertise for three age group, or maybe three different packaging of the product. One package which appeals the youngsters and another package which appeals the middle-aged people. There is no need, because it was found that liking and disliking or the propensity to purchase, that is not dependent at all on the age group. But sometimes you may find that yes, it depends upon age group. So what type of test would be done for that kind of case? Chi-square test. Okay. Now similarly, there is role of hypothesis testing in business analytics. For previous was role of hypothesis testing in data science. Now here, marketing campaign effectiveness. Okay, so that also we had done in detail how to do using a parity test. That suppose you have adopted a new marketing strategy. Now you want to decide whether that new marketing strategy actually improves the sales or it sales remains practically same. So your null hypothesis will be that sales remain practically same, while your alternative hypothesis will be that sales with new marketing strategy is greater than the sales with old marketing strategy. So then we can test, and whatever hypothesis testing tells us, accordingly we will decide whether to spend money on new marketing strategy or not. So comparing the average sale before and after launching a social media campaign using parity test. Okay, then customer retention strategy. So customer churn you want to prevent. That means you want to use various techniques for preventing your customer to go to your competitor company. So at that time you are trying various methods. Suppose one of the methods is this, that you have assigned the marketing company that send personalized email campaign. Okay, and again you may pay the marketing company, but if you have say 2 million customers, then you will not pay for all 2 million customers without testing, right? So you will tell first, make a small sample of 2000 or so customers, send your personalized email campaign and let me test if it actually reduces the churn, customer churn or not. So for that you can use two proportion or two-tailed Z test to compare the churn rate between the customers who received the emails and who did not receive the email. Again, the null hypothesis is that personalized email campaign does not affect the customer churn, and alternative hypothesis is that sending personalized email campaign reduces the customer churn. Okay. Then product launches. So before you launch a product, if you are going to spend hundreds and hundreds of dollars for each city, okay, and for that a new marketing campaign you want to launch and everything, but you suppose your operations are over 100 different cities or 500 different cities, then you will not launch the marketing campaign in 500 cities directly, because that would be too costly. You will launch it in maybe 4 cities in 4 different regions as a sample, okay, and you will check that I am launching new product version, say iPhone, instead of i13 I am launching i14, but first kind of prototype is launched, pilot project is done. That pilot project will tell in 4 cities whether the new version is preferred by the customers. Again, null hypothesis would be that old version of product iPhone 13 and iPhone 14 both are equally preferred. So that means that there is not much justification in increasing the price or spending huge amount of money on the marketing campaign, right? But suppose you get alternative hypothesis that after a new product is launched, the customer 90% of the customer preferred the new version of the product and they did not mind paying extra money for that. So then you will do a grand scale marketing over all the cities thereafter, right? But again, how you will test your hypothesis? Then you can use a chi-square test to analyze customer preferences for old versus new product. Then because of customer's preference, whether he likes and whether you can ask the customer a survey question, do you like the new product version iPhone 14 more than iPhone 13? And second question, are you feeling that the additional 5,000 rupees in the price compared in iPhone 14 compared to iPhone 13 is justified, right? So then these are categorical variables, yes or no. That is how the customer will respond. So that is why chi-square test is used. Operational efficiency test if new scheduling system reduces average wait time in hospitals. Now in most of the abroad hospitals, the patients don't like to wait for the doctor for a very long time, and it is a well-known problem that how to reduce the wait time for the patient, right? So for that, scheduling systems are designed, and you have applied new scheduling system. Suppose you have taken government contract of all the public hospitals of entire United States, but government will not give contract to you directly for all. It will tell that again, just put it in 2-3 hospitals and show me that your new scheduling system actually reduces the wait time in hospitals. So null hypothesis will say that with old scheduling system and new scheduling system, the average wait time remains the same, while alternative hypothesis will say that new scheduling system wait time is less compared to old scheduling system wait time. But again, which hypothesis is correct, that you have to decide by some statistical test. And in this case, paired t-test is the most suitable because it is the same sample and you want to compare the wait time before applying your intervention, that is changing the scheduling system, and after applying the intervention. So at that time, you can use a paired t-test. Okay. Then pricing strategies. Evaluate whether price drop will increase the average revenue per customer. This average revenue per customer is a very important metric. It is called ARPU. Customer is often called unit. So ARPU, average revenue per unit, right? Now, suppose your company wants to decide a sale, announce one sale for a one particular product. But if you announce a sale, say 60% sale, but 60% discount, or maybe 40% discount, and so 60% is the price, that is going to cause some revenue loss and profit loss to you. Now the question is that loss compensated by more number of sales so that average revenue per customer increases? Okay, so it is possible that originally with full price you are getting only 100 customers. Now you drop your price to 60% and you are getting suddenly 2,200 customers. So your number of customers has become suddenly, that means 220 times, right? So 22 times. So if you get 22 times more customers, then it is possible that ARPU will increase. Even though you are charging each customer less amount, your ARPU will increase. So again, null hypothesis will say that by giving discount, ARPU does not increase. But alternative hypothesis will say that after giving discount, ARPU increases. So conduct a two sample t-test comparing revenue before and after the price change, right? Now this hypothesis testing in e-commerce and the rest of the portion that we will do in the next lecture. So stay tuned and thank you.